Alright, let's set up the environment to run our app. I have set 2 terminal sessions to this setup. In the first one, we'll be running the Python application. In the other one is where we'll be running the Red Hat AI Inference server. First step is to set the Python virtual environment. Then, we need to create a .env file that will contain the document path variable. This variable should contain the full path to the PDF document we intend to analyze. It's important to double-check that we're setting in this variable a valid document path in our environment, since this is the input for our application workflow. In this example, we are setting the document example provided in the application GitHub repository. Once created the .env file and define the document path variable within it, we can install the necessary Python libraries. The application provides a requirements.txt file with a list of libraries that requires to be installed in the Python virtual environment to run correctly the application. We can run pip install -r requirements.txt to install all of them. Now, we need to open a separate terminal session where we'll be running the Red Hat AI Inference server. We need to make sure we're located in the path that contains the rice-cache directory. Otherwise, Podman will not be able to mount the required volume to start or provide the models. Once we are located in the correct directory in the terminal session, we can start the Podman container. We can see that the command to run the Red Hat AI Inference server instance typically involves podman run with specific parameters for model serving, port mapping, and GPU access. It provides multiple options that can be explored depending on each use case. You can check out the full example in the application GitHub repository in the readme file. Also, you can explore more options for available models in the Red Hat AI Hugging Face space in the RHAIIS documentation. The starting process could take some minutes, depending on the model size and current hardware specifications. Once the container finishes the starting process, we need to go back to our previous terminal, where we have configured the Python virtual environment. There, we can now execute our application simply by typing pythonapp.py. There, the application will be printing the executed workflow, starting with the document processing and chunking. Then the serve model analyzes it according to provided instructions. If the document complies with the provided rules, it will be approved. Optionally, we can open the app.py file and uncomment the last line in the application code, which contains an instruction to print the state graph in ASCII format. Then, we can save the changes and rerun the application. We can see now that after following the complete application workflow, it has also printed the state graph. We can check also the current GPU workload details. Alongside, we can verify the request sent via API from the application to the running Inference server instance.